This is Unit 1.7, Water Cycle and Availability. So we can't overstate the importance of water on Earth. It's vital for life. It moderates climate, so it keeps places from getting too hot or too cold. It sculpts the land through erosion and deposition. It removes and dilutes waste, and it's always moving through the water cycle. If you took all the water on Earth and you turned it into a sphere, right, you compressed it, you would see that it takes up very little space, not even as big as the entire US. So really, there may seem like there's a lot of water on the Earth, but compared to the total mass of the Earth, the total amount of water is very small. So the total global water, most of it is in the oceans, right, 96.5%, and that's all undrinkable, right, because it's full of salt. Fresh water that we can actually use is only 2.5% of the Earth's water. Of that amount, 2/3 of it is in glaciers and ice caps, although that's going down every day. Groundwater is 30%, also not necessarily accessible as the groundwater. And then surface water and other fresh water that's easily accessible is 1.3%. Of that 1.3%, most is ice and snow, right, separate from glaciers. Lakes is 20%, and then everything else is very small percentages. Only 0.02% of the Earth's water is available to us as liquid fresh water. So already there isn't that much water on the Earth compared to the Earth, but then what there is not really available to us. And so if you look at a map of the Earth, there's a lot of places where there's need for water, right? There's just not enough water for the demand. And so it's likely that conflicts between countries or within countries are going to happen due to water availability. Between countries, I mean, this is kind of already happening. If you look in Africa, there's a dam that's being built on the Nile upstream by Ethiopia. It's affecting Egypt downstream. So it'd be interesting to see how that plays out. Even in the US, right, the long-term drought, and it's not even really drought, it's really aridification that's happening in the West, is causing the states out there to have to rethink their compact on how they use the water, the Colorado River. Hopefully you are somewhat familiar with the water cycle. So there's lots of reservoirs, right? Water exists in the atmosphere, as clouds, water vapor. Oceans can evaporate water into the atmosphere. Water in the atmosphere can precipitate into ice and snow or rain. That water gets into surface flows like streams and rivers or lakes. It can also infiltrate into groundwater, which can go into surface water or things like the oceans. And then there are plenty of biotics, plants that take up that water, animals that drink the water, and then eventually it makes its way back up to the atmosphere. So let's look at some of these different processes and flows in the water cycle. So different transfer processes, things like infiltration, runoff, plant uptake, seepage, and precipitation. Like I said, there's also drinking or percolation. Some of the transformation processes, snow can melt into water, water can evaporate into water vapor, sublimation where ice, solid water just turns into water vapor, freezing, condensation, fog grip. Effects of climate change here have been that some places have seen increases of precipitation, some have seen decreases. Sea level is rising, and there's already a loss of ice habitat and freshwater water sources such as glaciers. Other human effects, we can pollute the water with chemicals, toxic metals, endocrine disruptors through eutrophication, where we put too much nutrients in there, things like algal blooms, and also thermal pollution from places like power plants. The largest storage is the ocean, followed by lakes and rivers and snow. Also, don't forget the glaciers. Clouds and the atmosphere hold a lot of water, just not for long periods of time. So other water vocabulary that you should know, and some of these we're going to come back to later as well. We're going to do a whole activity on aquifers. So should know what an aquifer is. That contains groundwater, artesian wells where water comes out under pressure, confined aquifers where aquifers are between layers of clay, groundwater where water's in the ground just generally, surface runoff when water doesn't infiltrate to the ground but runs along the surface. Unconfined aquifers are at the surface of the earth and they recharge directly. Water table is how high the water is in the ground, and then watershed is the whole drainage basin. And we'll be doing unit 4.6 on watersheds specifically. So here's a nice diagram that shows how groundwater, like water, infiltrates into the ground, whether it's through bedrock that's fractured or sand and gravel. Plants grow their roots in the ground and they can get water that way, but the water goes down as far as it can go, and where it can be accessed, that's the aquifer. You can also have things like sand and gravel aquifers that might be considered confined because it has a silty layer on top. Surface runoff when water does not infiltrate into the ground or evaporate into the air, then it runs into bodies of water. Watersheds are also called drainage basins. This is a land area that delivers runoff, sediment, and any dissolved substances into a stream. Like I said, we're going to do a whole section on watersheds. That's going to be 4.6. But you can see them on maps where they're outlines, where everything that's within the outline drains to a specific stream or river. In the case of Maryland, we have the Chesapeake Bay watershed, where everything within that watershed drains to the Chesapeake Bay. Aquifers are where there are underground caverns or porous layers of sand or gravel or bedrock through which groundwater flows. I hesitate a little to say underground caverns because that's not common. It exists mostly in areas where there are lots of limestone. Mostly, aquifers exist as porous layers of sand and gravel. The water table is the level below which ground is saturated with water. Unconfined aquifers are at the surface and they are permeable with the water table. Confined aquifers are bounded above and below by less permeable beds of rock. That water is confined under pressure. Some aquifers can be precipitated by precipitation, but others are not. They can be recharged through rivers or streams or lakes. An artesian well is a well where it's drilled into a confined aquifer and it pushes water up at a location without a pump. So most wells require pumps to get the water out, but not an artesian well. So this diagram shows different parts of watersheds and aquifers interacting. This is a watershed in California, which is really like the San Francisco Bay watershed. Notice how it takes up most of the state. And especially in that center part of California is where a lot of the agriculture happens. More shots of California. And there's not just one water cycle diagram, but there are lots of ways to represent it. This is one way. You can take a look and see if this works better for you than other diagrams. There's also this one from the USGS. And then they can be more and less complicated, right? This one is more complicated. Of course, climate change is affecting where the water is. That's resulting in more forest, or not more forest fires, but greater intensity of forest fires. Places where the water is absent is experiencing drought, and then also hurricanes, possibly increased intensity due to climate change. So in all of these cases, it's important to know the cause and effects, right? So more or less precipitation can result in flooding or drought. If you increase irrigation and the uptake required for that irrigation, then you lose groundwater and deplete aquifers. climate change is resulting in a decrease in both land and sea ice, as well as a rise in sea level. All right, well, that is all for Unit 1.7. Please let me know if you have any questions.